I need to know where did the user touch on the screen. So if I ask the touch object, what is your location in the view, this is going to give me an XY coordinate of wherever the human's finger just went down. The only field I care about there is one of the axes of that finger press. And so over here, notice that I am, again, grabbing the finger's location. Then I'm updating the center of the paddle to be at a new point on the screen. I'm leaving its x-axis unchanged. And by unchanged, I mean just ask the paddle view where its current center is and get x and set it back equal to that value. But location is that of the finger. So I'm saying make your y coordinate match the y-axis of wherever the finger was on the screen. And because these events are being fired continuously, again and again and again, every few milliseconds, you have the visual effect of the paddle actually tracking the finger up and down. So how do we actually now make a game out of this? Well, we have the beginnings of the user playing. Now all we need is the ability to play against a computer. So let me go ahead here and open up Pong. And in Pong, just to spoil the effect, actually, let's not spoil the effect. It'll be a better cliffhanger if you see the end result first. So this time, just to spice things up a bit, I decided I don't want to draw the paddle by default by hand. I don't want to draw the ball by hand. I have Photoshop. I'm going to make these things myself. So I made here the paddle, which looks like, you can barely see it. Can you see it on the projector? No, but it's over there. It's white. It looks really good, though, on this screen. And now you're really not going to see the ball. I'll put the arrow at the ball. It's like a 4-pixel ball right there. OK, so that saved me a lot of programming effort. And frankly, it did. It's a lot easier to make a few pixels in a graphical editor and save them as a PNG or a JPEG. So that's what I did, though it's not strictly necessary. So how does this program get kickstarted? Well, here's my app delegate. It is calling, as usual, it seems, init with nib name. So let's go down now to my nib. And the nib, OK, so I have some stuff going on here. So this thing, and this thing are actually UI image views. So they're the same things as I used for Tommy before, but I scaled them down so that they don't fill the whole screen. So that's just where I put them by default. But we'll be able to move those image views because they're actually wrapped, again, in an object. Score left, score right, these are actually just UI labels. And I just aligned it in such a way that those words will disappear. They'll be replaced with actual numbers as score is actually kept track of here. So now if I look over in my view controller, let's see, actually, in my view controller, I have a kickoff method, which is interesting. That'll kick off the game, apparently. And now here I have a whole bunch of stuff inside. So quick tour. I have a constant declared up here. You might recall from C that you can use sharp define to declare constants. You still can in Objective-C. But what's better about this declaration of a constant versus the sharp define? Yeah, so this actually has a type associated with it. Sharp define simply does a find and replace throughout your code, which means there's no notion of type checking there. By declaring it as an actual const, it means I get all of the privileges afforded to a float in this case, so I can't misuse this or use it in the wrong location if something expects that particular type. Here I have an ivar that's of type CG_point to keep track of velocity, and velocity here will ultimately be initialized to this and on an x-axis and a y-axis. So a vector is velocity. I have a whole bunch of private properties, and most of these you can infer what they are. A pointer to the left paddle, the right paddle, the left label, the right label, the ball, score left, score right. And then also I implemented a pause feature so that if you background this application, it will actually pause the game and then reload it wherever it left off. Now I'm doing some boring synthesizing of all of these properties down here. So let's actually see what happens when I initialize this application for the first time. So 1, I'm initializing the scores to be 0. That's reasonable to do once and only once. 2, I'm initializing the ball's velocity to be a CG_point make. So velocity comma velocity, you can represent a vector with effectively a point. You just need an x component and a y component to represent that vector. So I'm just doing that to say we're going to go the same speed along the x-axis as you are on the y-axis. So that even as I change the ball's orientation, it's going to always go in the same speed. And now we need this timer. So just like in JavaScript, if you want to do something cyclically, listening for events, this thing's going to listen every 0.05 seconds for some kind of interaction on the screen. I need to essentially constantly check, is the ball touching the paddle? Is the ball touching the paddle? Is the ball touching the paddle? Or did it go off one of the sides? I need to keep checking that, just like in Scratch, if you use that language a year or more back. So let's fast forward down to any view. And this is all I have for view. In this game, because I've constructed a lot of it in the nib, I don't need to do as much in viewDidLoad, but I do need to start the game when the view comes into display. So after viewDidLoad, you automatically call it as a method called viewDidAppear. So just because it's been allocated doesn't mean the user can see it. When the user can actually see the state of the world, this method's invoked, so I'm going to pass the kickoff message to myself. So let's follow this these breadcrumbs to kickoff. Scroll up, scroll up, scroll up. All right, so kickoff. So by default, the game is going to be paused. The ball is going to be positioned in the middle of the board, and the gameplay will be paused. I'm going to update the scores to be equal to, and here's where we just have to do a bit of NSString math. I have a score left property, which is a number, an integer, and a score right. So I just need to convert those to strings so that I can display them on the screen. Here's how I'm going to center the ball. I'm going to locate it at 240, 160 pixels or points on the screen. And then I'm going to line the paddles. And this was a bit of trial and error, but I decided that this is where I want the two paddles to start, on the left side of the screen and the right side of the screen. Now, when the user actually starts moving, gameplay is going to be invoked. So the play method, the play method is going to be invoked every 0.05 seconds. So long as the game isn't paused, and the game will automatically be unpaused once the user starts interacting with the screen, thanks to some code, play is going to get invoked constantly, again and again and again. Think of that event loop that we talked about at the start of today. If the game is paused, don't do anything. Just return, and we'll ask the question again in a few milliseconds. Otherwise, go ahead and move the ball. And this is very similar in spirit to what we did with the paddle. But in this case, I want the ball to be self-propelled. So I'm going to move the ball from its current x coordinate plus the x velocity, comma, the current y component plus the y velocity. And then I need to detect goal. So if the center of the ball is less than 5, in other words, if it's within 5 pixels of the left in the screen, that means someone just scored a goal. It got too close to the end, so the guy on the right apparently scored, plus plus. I recall kickoff, so the ball goes back to the center thanks to the referee or whatnot, and we restart the game, but with the updated score. If instead it's 5 pixels to the right of the screen, so I have to do a bit of arithmetic to figure out what that is, because of the coordinate system, the guy on the left is going to get a score. Otherwise, I'm not going to do anything unless the y coordinate is actually really close to the top of the wall or really close to the bottom of the wall, in which case I'm going to perform a reflection with just a little bit of arithmetic where I flip around the velocity's y component so that if you're going 5 miles per hour this way, now you're going negative 5 miles per hour, so as to flip the ball in a reverse direction. So the end results here, oh, and the paddle is similar here. And the specifics of the code here aren't so necessary so long as you understand the overall framework of the game. Here I'm just checking, are you touching the right paddle, or are you touching the left panel? So if I then run this game, what we see here is a little game like this. And as soon as I touch the screen, the ball starts moving. And if I keep my finger on the screen and move up, I'm the guy on the right. The computer is the guy on the left. He's pretty much infallible, the way the game has been written. So really, just to prove that the score system works, I'm going to have to choke here and oh. So now he got 1 point. Of course, we can introduce a bit of AI ourselves. If I go here, I can make myself better by, let's do this. Pull up Attribute Inspector. And recall that before we did some scaling of Tommy's face. So here we just have to do, where is it? Tag mode, there we go. Scale to fill. OK, so save, reload. This is real AI now. So now I hit the screen, no hands. The sad thing is when I was making this joke in my head last night, I actually lost because it can still actually hit the bottom corner there. So this here is Pong. So today we look... Thank you. So this here is Pong, two-dimensional graphics. One of the themes today has been delegation and actually passing messages around. Next week we'll start looking at testing and how you can ensure your code is correct, case in point. But until then, good luck with Evil Hangman. We'll see you next week.